Number 7 is taken from Section 7 on converting parabolas and circles to descriptive form. Part A is number 1 from our worksheet. And we are wanting to graph and fill out some other information in regards to this problem. So it's the x minus 3 that's being squared. We want that on the right side of the equation. Whatever's being squared should be on the right side. So I'm going to flip this around. 8 times y minus 5 is equal to, in parentheses, x minus 3 squared. Remember, there's a 1, invisible 1 in front of that parentheses, so when you divide by 8, don't distribute the 8, divide by 8, you end up with y minus 5 equals 1 over 8 times x minus 3 squared, and then finish by adding 5. So y is equal to 1/8 times x minus 3 squared plus 5. That's the descriptive form that we want to use to find all the missing pieces. Starting with our vertex, we that minus 3 contributes to the x value, because it's with the x in there, and the 5 is our y value. So I'm going to plot that. And label it with a V for vertex. This parabola is going to open up. And I know that because it starts with a y equals, so it's opening along the y-axis, and because the 1/8 is positive, so it opens in the positive y direction. Our axis of symmetry, well, I'll get to that. So the line of symmetry, I'll come back to that. The focus comes from taking that 1/8 and setting it equal to 1 over 4a. So 4a is equal to 8, a is equal to 2, and a is the distance from the vertex to the focus. And because our parabola is opening up, we're going to go up 2 units from our vertex. And so that's going to be at 3, 7. Sorry, that's the focus, not the line of symmetry. Let me correct that. The directrix is on the opposite side of the vertex. In this case, it's a horizontal line. Again, 2 units from the vertex, the same distance, the vertex to the focus. And so this is going to be the equation y is equal to 3. And the focal chord endpoints line up with the focus, one on the right, one on the left in this case, and have a distance of 2a from the focus, which in this case is 2 times 2, or 4. So from the focus, I'm going to go right 4 and left 4 from the focus. And my parabola goes through the vertex and through these focal chord endpoints. And the one on the left is going to be located at -1, 7. The one on the right is going to be located at 5, not 5, sorry, at 7, 7. And lastly, the line of symmetry cuts through the focus and the vertex. That's what the line of symmetry is. And so this is going to be x equals 3. And now we have all the pieces we want for that problem. On to the next one. So here on part B, the y plus 2 squared is on the left-hand side. And we want to move it to the right-hand side. So we want to switch sides. By the way, this is taken from number 2 on worksheet 7. So when we switch sides, we end up with 4 times x plus 1 is equal to, in parentheses, y plus 2 squared. Don't forget there's an invisible 1 in front of the parentheses, so when you divide by 4, you get x plus 1 is 1/4 times y plus 2 squared, and then subtract 1. And we have the form that we want to work with. It should look like that. Okay, so here it's going to open in the positive x direction, so it opens right. We say positive because the 1/4 is positive. We say x direction because it's an x equals parabola. The vertex of this parabola, well, that y plus 2 contributes to the y value of the vertex. So we get a -2 for the y value, and the -1 contributes to the x value. So we can start by plotting that vertex at -1, -2. The focus, we need to take that 1/4 and set it to 1/4a, which tells us that 4a is equal to 4, a is equal to 1. So the distance from the vertex to the focus is 1, and we're opening right, so we're only going to the right one. So we have our vertex here, we got our focus there. And that is going to be at 0, -2. Put it in the wrong place again. Let me fix that. The directrix is located on the opposite side of the vertex, same distance away, so it's this vertical line, x equals -2. The focal chord endpoints line up with the focus in our distance of 2a from the focus, which in this case is 2 times 1, or 2. So 2 above the focus and 2 below the focus, and our parabola goes through the vertex and those focal chord endpoints located at 0, 0 and 0, 4. Lastly, our line of symmetry always passes through the vertex and the focus, which is the equation y equals -2. Part C is taken from number 8 from our worksheet. And here we need to do a little work to get it into the form we would like. I'm going to factor a 2 out of the first two terms to start. So y is equal to 2 times x squared minus 14x, leave a little space to complete the square, plus 98. When completing the square, we take the -14, cut it in half, and square, which is -7 squared, which is positive 49. So we want to add 49 inside the parentheses. But 2 times 49 is 98. So by putting a plus 49 there, we're adding 98 that wasn't there. So we need to compensate by subtracting 98. Then we factor and get x minus 7 times x minus 7 plus 0. Clean this up a little bit, and you get y is equal to 2 times x minus 7 squared. That's the form we're going to work from. This is going to open up in the positive y direction because it's a y equals parabola and the 2 is positive. The vertex is going to be 7, 0. The 7 is with the x, so it contributes to the x value of the vertex. and there's a plus 0 at the end, which we don't see, and that's our y value. So when I plot this, 7, 0, opening up, just a little sketch. We don't have to do the other pieces, the focus, the directrix, the focal chord endpoints. It's not asking for that. It is asking for the line of symmetry, which cuts right down the middle through the focus and the vertex, which is going to be x equals 7. It asks for the number of x-intercepts, which it touches the x-axis only one time at the vertex, and the number of y-intercepts. Now the way I graphed this, it doesn't look like, well, what I had graphed is not touching the y-axis, but those arrows mean that they're going to continue to move to the left and to the right, so eventually the left side of that will cross the y-axis in one spot.